Hello my dear students, welcome to IMS GATE Academy. In this particular session, we are going to discuss the important GATE questions which are asked in the last year, GATE 2023. And this particular subject is common for 4 branches, EC, Electrical, Instrumentation, Computer Science. I know that some of you already attempted the GATE paper, okay, in this year 2023. But you people might have attempted the questions related to your particular branch, right? Suppose if you are from EC, you might have attempted the questions related to EC. And similarly, if you are from Electrical, you might have attempted the questions from Electrical, right? But here in this particular session, so regarding the first 4 chapters like number systems and codes, Boolean algebra and K-maps, logic gates, and then combination circuits, regarding these 4 chapters, whatever the GATE questions asked in this year 2023 for all the 4 branches, we will cover in this particular session, so that the students whoever attended our classes, either physical or online, and even other students, okay, whoever having the knowledge of digital circuit subject, if you want to check the confidence level regarding this particular subject, this session is very much helpful for all of you. So all of you kindly share this video link with all of your friends so that they also will attend this session live and they also will get benefited from this session, right? Okay. So in this particular session, for every question, I will show the question and I will keep the timer either 1 minute or 2 minutes or 3 minutes according to the level of the question. And you people can refer your notes and you can try and you can mention your answer in the chart. After that, I will disclose. Okay, I will discuss what is the correct answer key and I will discuss the explanation for that question. And based on the possibility, I will discuss some questions in 1 method only. Some questions I will discuss 2 methods or even 3 methods also, right? So that you will get complete overview of the first 4 chapters, whatever the questions are asked in this particular 2023 year, okay, right? So all of you kindly share this video link with all of your friends. We'll start the session. How many of you are eagerly waiting for the session? So please respond in the chat. I will show the first question. Yes, I hope all of you, right? Yeah. So this is the first question which is asked in GATE CS 2023 for 1 mark, and this question is related to the number system conversion. Yeah, this question is related to the number system conversions. So all of you try to attempt this question and whatever the answer you are getting, you can mention in the chart. Yes, very good, Krishna Vira. Very good. Others also please try, and whatever the answer you are getting, you can mention in the chart. Yes, 110 is the correct answer. Very good. So here they have given one number. They have given one number 132, and that belongs to the base 4 number system. That belongs to the base 4 number system, and they're asking the equivalent number in base 5. Yes, very good, Amit Goyal, very good. 110 is the correct answer. So whenever we want to find the equivalent number in any other number system, okay, so first of all, whatever the given number is there, try to convert into the decimal. Okay, after that, the decimal number you can convert into any other number system according to the requirement. Okay, so first of all, let us convert this number 132, which belongs to the base 4 number. First of all, let us convert this one into decimal. Yes, very good, Janavi, very good. All of you are getting correct answer, very good. So here we are having 3 digits, all belongs to the base 4 number, right? So that means each and every digit will be having the respective position weight in powers of 4. So 4 power 0, 4 power 1, 4 square. Four power 0, 4 power 1, 4 square. So multiply each and every digit with the respective position weight, and then you can add, right? 4 square is nothing but 16. 16 into 1 is 16, plus 4 power 1 is 4. 4 into 3, that is 12. Then 4 power 0 is 1. 1 into 2 is 2. So 12 plus 2 is 14. 14 plus 16, you are getting 30. This is the decimal number 30. This is the decimal number 30. Now we have to convert this decimal number into base 5. So what operation we will perform in order to convert the decimal number into base 5? Which operation? Repetitive division or repetitive multiplication? Here we are having the decimal number 30. We want to convert into base 5. Yes, see, in the base 5 number system, for a single digit you can represent the values ranging from what? 0 to 4. So that means whenever you are dividing any number with 5, okay, any integer number with 5, then you will get the remainders which belongs to the digits of the base 5 number system, right? Yes, very good, Amit, very good. So here we will perform the repetitive division with 5. 5 6 are 30, remainder is 0. Then 5 1s are 5, remainder is 1. Here I am placing the quotient, here I am placing the remainder. Yes. Then similarly 5 zeros are 0, remainder is 1. We will continue like this repetitive division process till we are getting quotient as 0. Once if you are getting quotient 0, you can stop the process, and whatever the remainders we got, we will consider in the reverse order. We will consider in the reverse order while we are placing the digits from left to right. So here the last remainder that you got, that will be your starting digit. Then next one, after that the first remainder which you got, that will be your last digit. Okay, so here 110 base 5, 110 base 5. Whatever the remainder you got first, that is your last digit, while you are placing the digits from left to right. Okay, in this way what we have done, we have considered the given number, and then we have found the equivalent decimal number, and from there we have converted the decimal, we have converted into base 5 number. Okay, this is one method. Say for example, if you are having, okay, so here we are having radix 4 number. Okay, radix 4 number. For the timing, I will discuss one more method. Say for example, you are having radix 4 number. Okay, here actually in order to get the base 5 number, first of all you should get decimal number. But before getting decimal number, for the timing, let us discuss how to convert base 4 number into base 16. How many digits if you do the grouping, so that you will get the digits corresponding to base 16. Any idea? Just to have the idea regarding base 4 number system to base 16 conversion. So for that sake, I am discussing the second method. Base 4 number, if you are having the digits, if you want to convert into base 16 digits, how many digits we have to do the grouping? Yes, very good, Krishna Priya, very good. 2 digits. See, it is very simple. So in the classes, you might have studied regarding binary to octal number system. Similarly, binary to hexadecimal number system. So there, if you observe, the digits belongs to, you are having the digits belongs to base 2. And here you are having 8. 8 you can write as 2 power 3. Similarly, 16 you can write as 2 power 4. So here the power indicates how many digits you have to do the grouping. Say for example, when you are having binary number, if you do the grouping of 3 bits, then you will get the corresponding octal digit. Okay. Similarly, if you are having binary, if you want to get hexadecimal, you have to do the grouping of 4 bits. Then you are getting the corresponding hexadecimal digit. So that means here whatever the base you are having, that is nothing but your radix or base of one number system. Okay, that in terms of that one or in powers of that base we are converting. Wherever possible you can apply. So that means here 16 is there, but here 4 is there. So this 16 we can write as 4 square. 16 we can write as 4 square. So that means here 4 is nothing but base of this number system, and here the power indicates how many digits we have to do the grouping. So that means if you do the grouping of 2 digits of base 4 number system, we will get the corresponding hexadecimal digit. Okay, same logic will applicable. Suppose if you are having base 3 number system, if you want to convert into base 9, 9 we can write as 3 square. There also you can do the grouping of 2 digits, so that you will get the digits correspond to base 9. Wherever you are getting like base r to base r power n. So for generalized case, I am mentioning like base r to base r power n. Right. So here we are having 132. The given number is 132. So now we want to convert into base 16. Base 16. So for that we have to do the grouping of 2 digits. Okay, here 3 2 we have done grouping, and here we have to do the grouping of 2 digits, but actually we are having 1 digit only, right? So the leftmost digit you can put simply 0, because leftmost side if you are placing 0, those are insignificant. So that means it is not changing the value at all, but based on the requirement you can put simply zeros. Okay, right. So that means here we are getting 2 numbers. Just for reference I will mention here. So here 0 1, 0 1 belongs to base 3, that is 2 digit number, and another number we are having 3 2. 3 2, sorry. 0 1 base 4, and then 3 2 base 4. 3 2 base 4. Okay, right. So whatever the earlier concept we have discussed, when you are having base 4, the position weights will be in powers of 4, right? The same logic. But here we have considered only 2 digits. If we have considered only 2 digits, then the position weights will be 4 power 0, 4 power 1. That's all. 4 power 0, 4 power 1. Okay, right. So here anyway this digit is 0, so equivalent value you will get 0. Same. 0 into anything is 0. Then 1 into 4 power 0 is nothing but 1. So you are getting simply 1. This is the corresponding decimal number, and since we have done grouping of 2 digits of base 4, and it is equivalent to base 16 also. Same number. Okay, right. Now here in this case 4 into 3, that is nothing but 12. Then 4 power 0 is 1. 1 into 2 is nothing but 2. So 12 plus 2 is nothing but 14. Now this 14 is actually the decimal. 14 is the decimal number. Okay. So you can observe here, whenever whatever may be the number of digits you may be having which belongs to any number system, when you are finding the equivalent value, that equivalent value by default you will get decimal number system. Right. So that means here 14 is the decimal, but our requirement is what? Base 16. So in base 16 we can write 14 as E. 14 as E. I hope it is clear for everyone. See, 0 to 9, when you are getting the equivalent value, the corresponding decimal number, the corresponding hexadecimal, both are same. But the moment from 10 to 15, if you are getting equivalent value, then 10 to 15 is fine with respect to decimal. But with respect to hexadecimal, we won't represent 10 to 15 with the normal numbers, right? We will use the alphabets A to F. Okay, that is the reason we have to convert. That's all. Now regarding 0, 1, we got 1. 0, 1, we got 1, and regarding 3, 2, we got E. So now we have converted base 4 into base 16. Okay, now this base 16 number we have to convert into decimal. Okay, so for that you can place the positional weights 16 power 0, 16 power 1. So 16 into 1, that is 16, plus 16 power 0 is 1. 1 into E is nothing but 14, right? 16 plus 14, that is nothing but 30. So here 30 is the decimal number. Okay, just for practice I have discussed the second method. Here directly we are getting the same decimal number. Once if you are getting the decimal number, you can convert into base 5 by doing the repetitive division. Okay, so because some of you might not be having the idea regarding the conversion of base 4 to base 16, so just for practice I have discussed that method. Is it clear for everyone regarding base 4 to base 16? I hope it is clear, and this particular procedure you can apply whenever you want to convert base R to base R power n, whenever you are getting exactly powers. Okay, whenever powers if you are unable to get, that time directly only one method, you can convert the given number which may belongs to any other number system. First of all you have to convert into decimal, that decimal number only we have to convert into any other requirement according to the base. Okay, whatever the base we want to get, so accordingly we have to convert. Okay, I hope it is clear for everyone. Now let me tell, okay, now all of you please respond. How many of you are eagerly waiting for the third method for this question? How many of you are eagerly waiting for the third method? Yes, I hope all of you are eagerly waiting, right? Yeah. So here the decimal number either first method or from second method you got the, for the given 132 is a 3-digit number which belongs to base 4, right? The corresponding decimal equivalent you got 30, that you got 30. Okay, that one I am considering as a reference. Now our requirement is we have to convert into base 5. We have to convert into base 5. Now see, up to here everyone got 30 either in the first method or second method. Okay, now from here how to write? Say for example, after getting 30 you have to do repeated division, right? So with this method you are getting the equivalent number this one. Even without doing this one, how easily you can write, that one I am giving here in the third method. Say for example, when you are having single digit in base 5, so then you can represent the minimum value is 0 and the maximum value that you can represent 4. 0 to 4. 0 to 4 belongs to base 5 number system, right? So if you are having the single digit, then starting value is 0 and maximum value is 4. Okay, and when you have converted into decimal equivalent, range will be same, 0 to same 4 only, 0 to 4 same. Now if you are having two digits in the base 5, if you are having two digits in the base 5, the starting digit or minimum value will be, both the digits are having the value 0. Both the digits are having the value 0. Now the maximum possible number that you can represent in base 5 is 4. Just like here, with the help of single digit, minimum value is 0, maximum value is 4, same concept. Here I have considered two digits. Now can you tell what is the corresponding maximum value in the decimal? Obviously minimum value will be same. So all of you try to tell me what is the equivalent value in the decimal for the maximum. Similarly I am considering 3 digits. 3 digits in base 5. Then the starting value we can represent all the digits are zeros. Then maximum value we can represent all the digits are 4. Now when you convert into the decimal equivalent, obviously the first number will be 0. Now can you guess what is the maximum value in the decimal equivalent? See, it is very simple. Here 5 power 0, 5 power 1. So 5 into 4 is 20, 20 plus 4, that is 24. 24. Or it is very simple. I will give the another shortcut also. Say for example, when you are having single digit in base 5 number system, 0 to 4, 10, 0 to 4, 5 possible values we are representing. Yes, very good Krishna Priya. Very good Bharat. Yes. Okay, now I am giving the shortcut. Okay. It is very simple. Say for example, when you are having one digit which belongs to base 5. Yes, very good Janvi, very good. Yes, very good Krishna Priya. Yes, this answer is 124, correct. 124. See, here also you might have followed the same procedure like 5 power 0, 5 power 1, 5 square. After that, when you multiply each and every digit with the respective positional weight, after that adding, from there you will get the same number. Okay, but I am giving one more shortcut also. Say for example, when you are having single digit, then for that single digit 0 to 4, that means 5 possible values we are representing. Whatever the base you are having, that many possible values. But since we are starting from 0, maximum value that you are getting is what? 5 minus 1. 5 minus 1. Regarding this one I am telling. So here 5 minus 1. So here we are having single digit, power is 1. Okay, 5 power 1, that is 5 minus 1, that is nothing but 4. Similarly here you are having 2 digits. So regarding this one, 5 square minus 1. 5 square means 25 possible values. Since we are starting from 0, maximum value we have to subtract 25, from there 1, right? So 25 minus 1, that is 24. Similarly here we are having 3 digits, right? So that means 5 power 3 minus 1. 5 power 3 minus 1. 5 cube is nothing but 125. 125 minus 1 is 124. I am giving all the possible shortcuts so that based on the requirement you can apply whichever shortcut you require so that you can solve the questions in less time. Okay, right. So why I have discussed this much, you can observe now. See, here we got the decimal number as 30. Now you can observe the range. If you are using single digit, the maximum that you can represent is 4 only. And if you are having 2 digits, the maximum that you can represent 24 only. But we have to represent what? 30. We have to represent 30. So that means 2 digits are not sufficient. 2 digits of base 5 are not sufficient. Obviously, we have to go for third digit. When we have considered 3 digits, we are getting range as 0 to 124. Obviously, the decimal number 30 is falling in this range, right? So that means now we can represent the decimal number 30 by using 3 digits which belongs to base 5. Okay. So just for understanding purpose, here I have mentioned the range. Okay, right. Now the moment you understood that we require 3 digits which belongs to base 5 number. Okay, which belongs to base 5 number. So I am considering 3 digits. And I am placing the corresponding positional weights like 5 power 0, 5 power 1, 5 square. Now just observe, with the help of 2 digits we are unable to represent 30. Okay. Now when you consider only this one, here since you are having base 5 number, each and every digit you can represent 0 to 4 like trial and error method. But here for this question we can easily solve. That's why I am discussing the third method. 5 square is nothing but what? 25. So that time if you consider the digit as 1 into 25 is nothing but 25. Now 25 is less when compared to 30. So now consider the next position weight. You are having 5 power 1 which is nothing but 5. So that means now here also I am considering 1. 1 into 5 is nothing but 5. Yes, 25 plus 5 is nothing but 30. So that means this digit value will be 0. That's all. Okay, 25 plus 5 plus 0 which is nothing but 30. So this 30 is the decimal number. The corresponding base 5 number is this one. How many of you like the third method? So please respond. how many of you understood and liked the third method? Everyone knows that the repetitive division, that method already we have covered in the first method. Okay, so just for understanding purpose, okay, just to give the some shortcut for this question, I have given the third method also. All of you please respond, how many of you liked the third method? Here I have converted the decimal number into the equivalent base 5, but for here I haven't followed the repetitive division, but I followed like I observed how many digits we require, and from there I have put the positional weights, and for every digit you are having 0 to 4 possible values, but since the number is very small 30, we can easily, you know, the moment when you are considering one positional weight, by adding which positional weights you are getting 30, simply just like when you have considered like binary to decimal equivalent, there you used to put that particular digits as 1, right? The same logic here also, but since you are having base 5, each and every digit you can represent 0 to 4 based on the requirement. That is the only difference. That's all. I hope it is clear for everyone, right? Yes. Now the next question, which is asked for instrumentation in 2023 for 1 mark. So all of you give a try. This is a simple question which is related to XOR operation. Yes, very good, Krishna Priya, very good. Option D is the correct one. Yes. This is a simple question related to XOR operation. So here you are having one set, okay, 4 equations are there, and here another set you are having, you have to match the, among this you have to make the pair. Yes, very good, Bharat, Janavi, yes, all of you are getting correct answer. So I hope everyone knows the standard formula regarding A XOR B. When you are having 2 inputs, the A XOR B is nothing but A bar B plus A into B bar. A bar B plus A into B bar, right? Okay. So by using this particular equation, you can consider one set and you can verify to which one it is matching. Okay. Say for example, first one if you consider X exclusive or X. So here both A and B are X. So that means in place of A you can substitute X. Similarly in place of B you can substitute X. So X bar into X 0. Similarly X into X bar 0. So 0 plus 0 is 0. So for first one we are getting Q. First one we are getting Q. So regarding that we are having 3 choices. 3 choices. As of now we can eliminate option C because here 1 is matched to P, but we are getting 0. Okay. Now let us consider the second one. Second one you are having X exclusive or X bar. X exclusive or X bar. So here in place of A you are having X. In place of A you are having X. Next, in place of B you are having X bar. In place of B you are having X bar. Now B bar is nothing but X bar whole bar, so which is nothing but X. Directly I am writing. So X bar into X bar is nothing but X bar plus X into X is nothing but X. So X plus X bar is nothing but 1. Okay, so that means 2 is matching to P, but here 2 is given to R. So these two options you can eliminate. So option A, option B you can eliminate. So already option C we eliminated. So here option D you are having 2 matches to P. So for this question, the moment when you have calculated regarding 2, okay, x exclusive or x bar, for this the moment you are getting 1, okay, with the help of that you can directly choose option D for this question. Yes or no? You can observe here in, see, this question is what? MCQ. Only one option will be correct. Only one option will be correct. Just look at the choices. See, you might have solved in the conventional like this method. So from this method also, luckily after solving the second equation you are able to get. But here you can observe this particular choices. Here you are having, you can observe case by case, like regarding P. Regarding P, here only one column regarding P among the choices. Okay, here only one place, and here only one place, here only one place. That means the moment regarding P, if you are able to calculate or if you are able to identify among this particular set which one is giving the output value as 1, with the help of that, whether you are solving remaining 3 or not, with the help of that, for this question luckily you can able to put the correct answer. That is the reason whenever you are getting MCQ, okay, instead of following regular method, okay, first read the question and then have a look at the choices. Okay, suppose sometime what will happen, with the help of, by observing the choices, you will come to the shortcut method. Okay, by finding which equation we can attempt the question correctly in less time. Okay, ultimately in the GATE exam, two things are playing a role. One is getting accuracy and another one is speed. Both are important. Okay, okay, this is the conventional method. Now the same question we can easily solve whenever you are having XOR related. So that time better you can use the truth table of XOR. Okay, from the truth table of that one also you will get the same thing, and you will get, in fact you will get the answer quickly. Okay. I hope everyone knows regarding the XOR truth table. So directly you can place the values 0, 1, 1, 0, 0, 1, 1, 0. Now first case you are having both the variables are same. Both the variables are same. So that means you can observe the first row and last row. First row and last row regarding A and B. Both the values are 0 or both the values are 1. Here output we are going to get 0. So that means, so 1 matches to Q. Okay. So already we got option D. So I am just verifying that. Next, another second one. X, first variable is X, second variable is what? Corresponding complement. That means if you have chosen first variable as 0, second variable is complement. 0 complement is 1. Similarly, first variable is 1, complement of 1 is 0. For these two cases, we are getting output as 1. Output as 1. Okay, right. So 2 is matching to P. And similarly, X exclusive or 0. X exclusive or 0, we can write this one as 0 exclusive or X by using which law? By using which law we can write like that? Similarly, the last one. Last one, you are having X exclusive or 1. X exclusive or 1 we are having. This one we can write as 1 XOR X. By using which law we can write like this? I hope all of you studied, right? Here whatever the two variables are there, we have interchanged. After interchanging also you will get the same functionality. That will satisfy which law? Commutative, right? By using commutative law we can write like this. Now here you are having starting variable as 0. Starting variable as 0. You can observe here starting variable 0, first two rows you are having, and now when you look at the second variable and the output, whatever second variable you are having, exactly the same thing you are going to get, right? Yes, very good, Jandhyam, very good, commutative law. So in this case you are getting the second variable is B, but here in this case second variable is X, so that is nothing but X. Okay, so 3 yes, 3s. And then last one, x exclusive or 1, we have written as 1x or x. So regarding 1, you are having last 2 rows. Now when you closely observe this second variable and the final output, 0 becoming 1, 1 becoming 0. So that means complement of b variable. Complement of b variable. So that is nothing but b bar. So in this case, second variable is x. So its complement is x bar. Okay. So in this case, 4 is matching to r. Okay. In this way, even for this particular question, the moment if you are getting for the second case, like 2 is matching to p, with the help of that, you can choose option D, because 2 is matching to p, only one choice, only option D, right? Okay, just for understanding purpose, I have discussed the tabular form. Okay, from the truth table, you can solve any question related to Boolean algebra or related to logic gates. If the question is completely related to XOR, you can easily write the equivalent value or equivalent expression from the truth table. You can write easily and you can write in less time. Okay. Yeah. So all of you answer this simple question. What is the relation between 2 input XOR gate and 2 input OR gate? So here when I mention relation, so you can mention either with respect to like similarity or you can mention with respect to difference. When you have considered 2 input XOR gate, 2 input OR gate. So for the time being, I will write the truth table for XOR gate and then OR gate here. Meanwhile, you can mention your answer in the chart. Regarding the relation between 2 input XOR gate and 2 input OR gate, what is the similarity or what is the difference between these two with respect to inputs? When you have observed the truth table, what was your observation point? Regarding XOR, this is the output. Regarding OR gate, this is the output. Just observe the first 3 rows. 0, 0, 0, 1, 1, 0. First 3 rows, your XOR gate truth table, OR gate truth table, both are same. 0, 0, 1, 1, 1, 1. It is same. XOR gate truth table, OR gate truth table for first 3 combinations same, right? Yes, very good, Jandhyam, very good. When you have observed for the last case 1, 1 combination, OR gate is producing output as 1, but XOR gate is producing 0, right? So that is the reason. Yes, very good, Krishnapriya, very good. So that is the reason here when you observe the term exclusive OR, okay, so that means XOR gate is nothing but OR gate only, but it excludes one combination when both the inputs become 1. Okay. Other than that combination, remaining all the combinations, your XOR gate and OR gate both are same, but it violates or it excludes one combination when both are becoming 1. Actually, OR gate is producing 1, but here XOR gate instead of 1, it is producing 0. That is the reason the name exclusive OR has given for the XOR term. Okay, right. Now, next question which is asked for instrumentation 2023 for 2 marks, and this question is related to the Boolean function simplification. Okay, so all of you give a try. Yeah, Bharat, you got the correct answer. Krishna Priya and Janavi, you are almost closer to the answer. Yes, very good, Deepu, very good. Actually, here they are asking the minimized function. Minimized function. Yes, very good, Krishna Priya. They are asking the minimized function. So, since the question is regarding minimization, okay, obviously since you are having 4 variable, okay, better you can use the K-map only. Yes, very good, Deepak, very good. All of you are getting correct answer. Yes, very good, Janvi. Yes. So, you can draw the 4 variable K-map. So, here the variables given wx and then yz 0 0 0 1 1 1 1 0. This is the gray code for 2 bits. Similarly, here you can place the 2-bit gray code 0 0 0 1 1 1 1 0. So, together we are having 4 variables, right. So, first of all, here you are having min terms. So, that means for these input combinations, output is what? 1. Okay, in the respective min term positions, you can place the ones. Okay, 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. I hope all of you got the same K-map for the given function. Now, for understanding purpose, let us do, okay, even though question is related to minimization, okay, but first of all, let us discuss regarding the prime implicants, essential and redundant, etc. Okay, so first of all, let us do all the possible groupings of adjacently placed ones in decreasing powers of 2. So that means here you are having 4 variable K-map. So first of all, check for grouping of 2 power 4 adjacently placed ones. Is it possible or not? It is not possible. Then go for 2 power 3. Grouping of 8 adjacently placed ones. That is also not possible. Then go for grouping of 2 square. Okay, in this way decreasing powers of 2. Okay, like that, tell me how many adjacently placed ones we can do grouping. Like that, how many groupings you are going to get? Obviously, here when you have checked grouping of 4 adjacently placed ones possible, like that, how many groupings are possible for the given K-map? Do all the possible groupings of 4 adjacently placed ones. See, you can do the grouping of 4 ones like this, and you can do the grouping of 4 ones like this, and then you can do the grouping of 4 ones like this. So that means total we are getting 3 groupings. All those are grouping of 4 adjacently placed ones only. Okay, right. From each grouping, you will get one particular product term, because we are doing the simplification with respect to min terms, right? So that particular product term we will call it as prime implicant. Okay. So here in this case, row wise x value is 1, that means x, and then column wise y value is 0, y bar. Okay. Next, for this row wise grouping, for this entire row, w value, x value both are equal to 1, that means wx. Okay, right. And similarly, from this grouping, row wise w value is 1, and then column wise y value is 1. Okay, in this way, whatever the groupings you got based on the possibility adjacently placed ones in decreasing powers of 2, from each grouping, whatever the product term we are getting, initially we will call it as prime implicant. Initially we will call it as prime implicant. And then among these groupings, whichever groupings are compulsory, then that particular prime implicant we will rename as essential. Now just observe, when you consider this particular grouping, okay, with respect to this one or with respect to this one, except this grouping, there is no other grouping. So that means this grouping is what? Mandatory, compulsory. That means this particular prime implicant is nothing but essential. Similarly, if you observe this particular grouping, with respect to this one or with respect to this one, except this grouping, there is no other grouping. That means this grouping is also must and should, which is essential. Now when you observe this row wise grouping, row grouping, even if you have removed this row grouping, okay, here actually you are having 4 ones, these 2 ones are having some other grouping, these 2 ones are having some other grouping. That means even if you not done this grouping, all the 4 ones are having some other groupings. That means this is just prime implicant, that's all. This is just prime implicant. Now, so that means here for the given K map, total we got 3 prime implicants. Number of prime implicants are 3, out of which when we have checked the condition for essential, okay, or compulsory, according to that we come to know among those 3, 2 of them are essential. Okay, out of 3, 2 are essential, right? So now let us write the minimized function. In the minimized function, you will be having, first of all, write all the essential prime implicants. Okay, here we are getting 2 essential. So this is what? X into y bar plus another essential prime implicant w into y. After considering all the essential prime implicants, now you can check whether the other prime implicants are we have to consider or not. If at all, if we have to consider, we will add, otherwise we can ignore. Okay, how to check that one? It is very simple. This particular term x into y bar you are going to get by doing the grouping of these 4 ones, right? So that means we have covered these 4 ones with the help of this grouping. Similarly, wy you got by doing the grouping of these 4 ones. That means in this K map, total you are having 8 ones. All the 8 ones are covered by these 2 essential. That means this particular grouping, row wise grouping, is not at all required. So that means you can ignore this one completely, because our requirement is what? Whatever the minterms here you are having in this Boolean function, all the minterms should be grouped. Okay, and luckily all those minterms were grouped by these 2 essential prime implicants. So in this case, this particular grouping is not at all required. So the final answer for this question is this one only, like x into y bar plus w into y. So that means now you can choose the correct option, x into y bar plus w into y. So that means option C is the correct one. Okay, now among these 3 prime implicants, okay, so just I am mentioning here for understanding purpose. Whenever the question is related to prime implicants or essential or redundant, that time this knowledge is required. That is the reason I am mentioning. Okay, but otherwise for solving, whenever the question is related to minimized function, most of you with the experience, okay, by solving good number of questions related to K map, okay, you can ignore the grouping of 4 ones like this. Okay, you might have done, some of you might have done only this grouping and only this grouping, that's all. Okay, when you get sufficient knowledge regarding K maps and with the observation of the K map regarding the placing of ones, with that knowledge, okay, you will avoid doing the grouping of 4 ones like this. Okay, because it is what? Redundant. It is not at all, it won't come at all in the final answer, that's all. It won't come at all in the final answer. Okay, so but whenever the question is regarding prime implicants, essential and redundant, that time you have to do all the possible groupings, right? That time you should have patience. But whenever the question is regarding minimized function, that time you will do only whichever groupings are compulsory or whichever groupings are required, you may do only that groupings, that's all. Okay, so just for understanding, I am giving the complete information. Number of prime implicants we are having 3, out of which 2 of them are essential. 2 of them are essential and 1 of them as redundant prime implicant. So that means even in the absence of that particular term, you will get the same functionality. That is the meaning of redundant. Okay, if you are considering in the function, that means it is unnecessarily present, that's all. Even in the absence of that particular term, if you are able to get the same functionality, then that particular prime implicant we will call it as redundant. So for generalized case, the total number of prime implicants are nothing but number of essential plus number of redundant prime implicants. Okay, suppose if there is no redundant prime implicant, that means 0. So all the prime implicants by default become essential, like that. Okay, I hope it is clear for everyone, right? So this is the question asked for the instrumentation branch in 2023 for 2 marks. This question is MCQ. Obviously one option will be correct, and here when you read the question, they asked with respect to minimum number of terms and smallest number of literals. Okay, whatever the minimized function you are having, try to get the function which is having least number of terms, and in the individual term also, based on the possibility, try to get the number of literals are getting minimized. Literal is nothing but the variable either in its normal form or in its complement form. Okay, right. The same question only I have considered now for all of you. The same question, whatever the given Boolean function is there, same Boolean function and same choices. I haven't altered. Choices I kept remain same and the Boolean function same. But now for practice, I have modified the same question as MSQ. Same question as MSQ. Now all of you read the question carefully and try to choose the correct options. Try to choose the correct options, because for MSQ either one option or more than one option can be correct. Okay, this is a very interesting question. This question actually having the scope of MSQ, but in the GATE paper they have given only for MCQ. So no worry at all. For practice, all of you are getting opportunity. Okay, the same question, same options, but I have modified the question as MSQ. Question framing I have little bit modified, that's all. So all of you give a try. Read the sentence frame. I have asked that which of the following is or equivalent. So according to this wording, try to choose the correct options. Deepak, have you attempted the 2023 paper, GATE instrumentation, earlier? Have you written the exam? Yeah, you haven't attended, right? Yeah, then no problem. Actually you are getting complete feeling of as though you are attempting the exam now only. Okay, because here most of the questions I have taken all the questions from all the branches, but currently the questions which are asked in instrumentation are coming more. Okay, in this particular session I have dedicated for 4 chapters: number systems and codes, Boolean algebra and K-maps, logic gates, and then combination circuits. Okay, so regarding these 4 chapters from all the branches, all the 4 branches, I am discussing the questions. Yeah, as of now we are getting 2 answers. Okay, is there any other possible answer? Whatever you have mentioned, 2 options are correct only. But is there any possibility to get one more option? Okay, no issue, I will give the clue. Okay, so whatever two options you got, those are correct. B and C are correct, but this question is MSQ, right? So you have to choose all the correct options. Then only you will get the marks assigned for that question. Okay, there is no partial marking, there is no negative marking in the GATE exam. Okay, but of course this question earlier question, it is a minimized function. Obviously one option will be correct, but for the timing, for practice, I have modified the question sentence framing into the MSQ, but I haven't modified regarding the given function and given choices. I have kept function and choices as it is, because this question is having the scope of MSQ. Okay, right. Now let us see. See, earlier we already done regarding the simplification with the help of groupings, right? Right. Now when you have observed, we already written this is the minimized function xy bar plus wy. So that means option C is the correct one only. Option C is the correct one. Equivalent function. Okay, right. And this is, in fact, this is the equivalent minimized function. Okay, right. Now when you observe option B and option C, xy bar both are matching. Next wy both are matching. So that means here we are having three terms. Out of three terms, two terms are same only. Now let us observe this term wx. Yes, that wx is nothing but earlier by doing the grouping of these four ones, we got that one wx, right? So that means if you are adding wx, that means it is equivalent only, equivalent function. Okay, equivalent for the given function only, correct? Yes. So that means option B is also correct. Option B is also correct. Say for example, if you are having option B, okay, the function if you are having, and if I ask you to simplify, by using which law we can do the simplification of this function so that you will get this function. How to do the simplification of the function given in option B to option C by using which law? If you don't have K-map, by using which law of Boolean algebra if you are using, so that you can do the simplification of this function into this function. Yes, very good, very good. Consensus law, right? Consensus law. Yes. Yes, very good, Krishna Priya, very good. Yes, that's why I used to tell that among all the laws of Boolean algebra, the consensus law is very much powerful and important law. Okay, because the other laws also important, but regarding consensus law, whenever you are supposed to solve or whenever you are solving any question related to the simplification with the help of basic rules and laws of Boolean algebra, that time in order to get the trigger, in order to apply consensus law, okay, getting that idea or trigger, it will take time. Okay, in general most of the students won't get that idea. Okay, but somehow that if you are able to get, and with the help of that consensus law, and regarding the two conditions, if both are satisfying, then obviously we can bring three terms to the two terms, right? Yeah. So now if you observe regarding w is present in this term and x is present in this term. In this particular term, y is missing, so that is present here normal form, and the corresponding complement is present here. So in that case, this particular term is a redundant, correct? Yes. So by using consensus law, we can do the simplification by using consensus law, right? Now up to here, we got to know that obviously option B, option C are equivalent for the given function. Now let us see when you are saying option B is equivalent, so here you are having wx. In option A also you are having the same term wx. Okay, so that means you don't need to verify whether it is satisfying or not. Now whether these two terms, okay, are related to this function or not, let us see. Or in other words, we will do in another way just for easy understanding. Wx we are going to get, okay, wx is nothing but this entire row. Wx is nothing but this entire row, correct? Okay. Now let us consider this term w bar xy bar. So that means regarding w the value should be 0, and regarding x it should be 1, regarding y it should be 0, because wherever complement is there, variable value is 0, correct? So now just observe regarding row wise 0 1 0 1. Regarding row wise 0 1 means second row, wx 0 1 means second row. Okay, and then regarding column wise you have to observe y value 0. Y value 0, here y value is nothing but first variable. Okay, so the first two columns are having y value 0. So intersection of row 2 and column 1, column 2. So that means we are getting these two ones. Earlier we got these 4 ones, now we are getting these 2 ones. Okay, I hope it is clear up to this point. So that means this term is matching, this term is equivalent only. Okay, whatever the given function is there, in order to get that one, the first term is satisfying and second term also. Now let us consider the last term. So here w value is 1, x value is 0, and then y value is 1. Regarding wx, you have to observe 1 0 row wise. So that means last row, wx 1 0 last row, and then regarding y value 1, column wise y value 1 last two columns, right? So intersection of row 4 and then last two columns, here you are getting 2 ones. So earlier we got 4 ones here, then 2 ones here, then 2 ones here. So that means option A is also equivalent function. What is the function they have given in option A? That is also equivalent. Yes, very few students will identify that option A is also equivalent. Okay, this is the magic in this particular question. That's why I have framed or modified this question into MSQ. Okay, obviously regarding option D, if you observe, here you are having x bar by w bar y bar. Okay, suppose for understanding or analyzing, let us verify. Here x value should be what? 0, y value should be 1. Okay, x value 0, so that means first row and last row, and y value 1, last two columns. See, here intersection of first row and last two columns. Okay, so here first row itself we don't have any min terms, right? Output we don't have 1. So straight away we can eliminate. So obviously option D is not equivalent. So for this question 3 choices are correct, A, B and C. How many of you liked this question? This MSQ, how many of you liked this question? This is interesting, right? In this way, whenever you get the time, okay, first of all, when you are solving any gate question, try to solve the question according to the context only. But later, whenever you get time, okay, try to contemplate, okay, in which cases the other options can be correct, okay, or is there any scope the same question as MSQ. Like that, when you are contemplating, then ideas will come. So from the same question only, based on the possibility, you can solve in n number of methods, in n number of variety, in the degrees also. So that you can, if you are studying like that, that means your basics are becoming strong, okay, and no matter, okay, whatever may be the level of the gate question regarding digital circuit subject, all of you can attempt the question and all of you can get the correct answer. Okay, whatever the option you are mentioning or whatever the answer you are mentioning, that will be correct, provided if you are learning thoroughly. But if you are not learning thoroughly, then you may attempt few questions correctly, but few questions like these tricky questions, okay, whenever you are coming across, okay, even though you are having good knowledge, but you are losing the opportunity, right? So that's why it will come with the practice, definitely, no problem. Here in the, since I have shown this question in the live, okay, some of you might not get the enough time to identify all the options, but no problem at all. But just try to follow whatever the idea or thought process that I am sharing in this particular session. So try to contemplate or apply whenever you get the time for solving the same question, so that you will get n number of methods and you will get, you know, in which cases other options can be correct. So in this way, if you learn, definitely whatever the preparation you are doing, that is having, you know, 100% effort, whatever you are putting, definitely you can see that particular effort in the result, right? Yes. So this is the question once again which is asked in the instrumentation branch in the 2023 for 2 marks, and this question is related to the logic gates. Okay. So but in this question, the surprise thing is, like, whatever the logic gates here they have mentioned, each and every logic gate is having the propagation delay, and they have mentioned also. And for overall circuit, you are having 3 inputs A, B, C. Regarding those values they have mentioned, and here each and every logic gate propagation delay they have mentioned. Whenever the propagation delay they have mentioned, after applying any input, in order to get the valid output, you have to consider that delay. Okay. Now the question is regarding the output y, they are asking the frequency. Okay. This is an excellent question which is asked in instrumentation branch for 2023. I will give 3 minutes time. All of you give a try. Do you require some more time? Yeah, Deepak, you can cross check once. How many of you are having the idea regarding when we have discussed in our regular classes, in the physical classes or online? We have discussed related to the full adder circuit diagram using logic gates, XOR gates, AND gates, OR gate, right? So that propagation relay concept, how many of you are having the awareness? The same concept you can apply here. Only the difference here in terms of the like timing instance, okay? But in general, the questions will be like propagation delay. correct? All of you please respond. How many of you are having the idea regarding the propagation delay concept that we have covered in the in the combination circuits, right? In the full adder circuit diagram. Yes, as of now we are getting option C. Okay, we'll see whether it is really correct or not. But all of you are well tried, very good. Okay, now let us focus here. Yeah, so here according to the given question, they have mentioned that A and B values are permanently 1. Okay, A value is 1 and B value is 1. A value is 1, B value is 1 throughout the operation. Just one second. Is this yellow color is visible for you, or shall I change the color? Okay, I will change the color. Just one second. Now this color is visible, right? Yeah. So A value is 1 and B value is 1 permanently. Okay, and C value is 1 initially. C value is 1 initially, because here the output of last gate they have connected as the feedback. So in order to understand the operation, we have to assume something initial value. Okay, so for the timing they have mentioned initially C value is 1. Okay, so that means we can consider like whatever A, B, C values you are having, we can consider at t equal to 0 nanosecond. At t equal to 0 nanosecond, we have given these inputs. Say for example, at t equal to 0 nanosecond, we have given A, B, C values. Okay, so that means now observe here the last gate you are having AND gate. AND gate is having two inputs. AND gate is having two inputs, but among those two inputs, one input you are getting at 0 nanosecond. One input you got at 0 nanosecond, and that input value is 1. Whenever you are having two input AND gate, when you know one value as 1, with the help of only this value, whether we can write the output, is it possible, or whether we require the other input value also. I am repeating question once again. Whenever you are having two input AND gate, the moment if you know one of the input is 1, whether we can write directly the output value without knowing the other input, is it possible? Not possible, right? Because for AND gate, if you know one of the input is 0, irrespective of other input, you can mention output as 0. But whenever you are having one of the input as 1, unless otherwise you know the other input value, you cannot write the output, correct? Okay, so that means we require the other input value. Okay, so for that, now just observe here we have to find out this particular input at what time instant we are going to get. Okay, and according to the given data, so first of all just mention whatever the logic gate delay you are having. For your reference, you can represent inside the logic gate. Okay, AND gate delay they have mentioned 10 nanosecond, AND gate delay 10 nanoseconds, 10 nanosecond, and OR gate delay also same 10 nanoseconds, and then NOT gate delay is 5 nanoseconds. NOT gate delay 5 nanoseconds. Just for reference, I have mentioned the logic gate delay inside the block. Now just observe here both the gates are NOT gates, and we have applied for this NOT gate input at 0 nanosecond. Similarly, for this NOT gate also input at 0 nanosecond. Now, in order to get the valid output, here complement of 1, you will get 0, and here complement of 1, you will get 0. But you will get this 0 at 5 nanoseconds because this NOT gate is having propagation of 5 nanoseconds. Similarly, this NOT gate also producing at 5 nanoseconds because these two are like parallel paths, right? So at 5 nanoseconds we are getting. Okay, right. Now just observe, for this OR gate, both the inputs are 0. So 0 plus 0 means 0. You will get 0. But that 0 at what time you will get? Here you are getting, when you observe these two inputs, both the inputs you are getting at 5 nanoseconds. Okay. And at 5 nanoseconds you are getting both the inputs. Now after you have applied the inputs, now this OR gate, in order to produce the valid output, it is taking 10 nanoseconds. So that means you have to add these two delays, right? 5 nanosecond plus 10 nanosecond, that means 15 nanosecond. 15 nanosecond. Now just observe. For this AND gate, one input we are directly getting at 0 nanosecond, but other input actually we are getting at 15 nanosecond. Actually we are getting at 15 nanosecond. Now at 15 nanosecond, since you are getting input as 0, 0 and 1 is nothing but 0. So 0 and 1 is nothing but 0. Now this output you will get at what time? All of you please respond. Here output of AND gate you are getting 0 at what instant of time? See, it is very simple. Here 15 nanosecond, here 10 nanosecond. Together you can add. That's all. 15 plus 10, that is 25 nanosecond. So that means at 25 nanosecond you are getting 0. Okay. Now just observe. Initially at 0 nanosecond. See, this C is nothing but Y only. C is nothing but Y only. At 0 nanosecond you are having 1. Y value you are having at 0 nanosecond 1, but at 25 nanosecond that value becoming 0. That value becoming 0. Now let us consider that 0 as the input and let us proceed further. Okay. So now I am considering that 0 you are getting at 25 nanoseconds. Zero you are getting at 25 nanosecond. See, yes, very good Deepu, very good. So now since A input we have kept and B input we have kept at 0 nanosecond, so obviously this input is available at 0 nanosecond only. And regarding this NOT gate delay also, okay, since input is 1 you got at 0, that is available at 5 nanosecond only. But now the modification is going to happen in this particular path because here input modified at 25 nanosecond. Now once again the same logic. At 25 nanosecond we got input as 0. So once again NOT gate means complement. 0 become 1, but that will happen at 25 plus 5, that is nothing but 30 nanosecond. 30 nanosecond. Now in this case you got, for this OR gate you are having two inputs. One input you already having 0 at 5 nanosecond only, but now at 30 nanosecond you are getting other input as 1. 1 plus 0 is nothing but 1. 1 plus 0 is nothing but 1. Now this output 1 you will get at what time? 30 nanosecond plus 10 nanosecond. 30 plus 10, that is nothing but 40 nanosecond. At 40 nanosecond you are getting output of OR gate as 1. Now just observe. For this AND gate, initially only you are having this input as 1, but now at 40 nanosecond this input also become 1. The moment if both the inputs are 1, AND gate will produce output as 1. But that will happen at 40 plus 10, that is nothing but 50 nanoseconds. 40 plus 10, that is nothing but 50 nanoseconds. Right. So what is your observation? Initially according to the given question data, initially you're having output as 1, okay, but at 25 nanosecond this output becomes 0, and at 50 nanosecond it is becoming 1. Now if you continue further, it is very simple. Now if you observe the overall circuit diagram for one cycle like this, when you have understood, okay, what phenomena is happening here, okay, here this value is permanently fixed at 5 nanosecond instant onwards, and this particular input value is permanently 1 from 0 nanosecond instant onwards. Now if you observe this entire circuit diagram, now the magic is happening because of this particular path. That's all. That's all. See, the moment here output changes, that is coming here, because of that here output of NOT gate is changing, and because of that here OR gate output is changing, because of that AND gate output is changing, like this cycle only going. Now just observe 5 nanosecond, 10 nanosecond, 10 nanosecond, together 25 nanosecond only. For every 25 nanosecond here output is going to change. Initially if you are having 0, now it will become 1. After 25 nanosecond, 0, 1, 0, 1, like that. That's all. So for understanding purpose, whatever we have discussed, I will draw the corresponding waveform regarding the output. Now initially you are having 1 at 0 nanosecond. This is the waveform for Y. This is the waveform for Y. At 0 nanosecond we are having 1, but at 25 nanosecond it was changed to 0, and at 50 nanoseconds it become 1, and similarly at 75 nanosecond it become 0, and similarly at 100 nanosecond it become 1, and in this way this cycle will continue. Now tell me whether this particular waveform is a periodic waveform or not. Yes, it is a periodic waveform, right? See, you can observe whatever the pattern 1, 0, this particular pattern only getting repeated. So whenever any pattern of a particular waveform, if it gets repeated, then we will call it as periodic waveform. So then that particular pattern period we will calculate, that's all. So here together how much duration we are having? 50 nanoseconds. So here t is nothing but 50 nanoseconds. Okay. So regarding the output waveform Y, you got the time period as 50 nanosecond. Now the question is they are asking the frequency. Frequency is nothing but 1 by time period. So that is nothing but 1 by 50. Nano you can write as 10 power minus 9. Now this 10 power minus 9 you can bring into the numerator. It will become 10 power 9. For the time being I am writing it as 10 power 3 into 10 power 6 divided by 50. So 10 power 3 we can write as 1000 divided by 50. 10 power 6 we can write as mega. Here frequency units are hertz. So 0 will get cancelled 5 20 times. So that means you are getting 20 megahertz. So all of you please respond. Earlier Deepak and Jahnavi, you got 40 nanoseconds, right? Option C you got 40 megahertz. So that is not correct. Option A is the correct one, 20 megahertz. Is it clear? If you are having any doubt, you can ask. The correct answer for this question is option A, 20 megahertz. 20 megahertz. All of you please respond whether is it clear for everyone or not. Yes, I hope it is clear for everyone. Now let us proceed to the next question. This is the question asked in EC branch 2023 for 1 mark. This is a simple question based on marks. I am not putting any timer because all of you can attempt this question without using pen and paper also. That much simple question in general we used to cover in our regular classes regarding this particular mux with respect to implementation of logic gates using 2/1 muxes, right? So all of you give it a try. If you want, you can use pen and paper, okay, no issue at all. But this is a very simple question, silly question. That's why I'm not keeping any timer. Yes, very good, Deepak, very good. All of you give it a try. It is a simple question, direct question. That's why I'm not keeping the timer. Don't hesitate. Whatever the answer you are getting, you can mention in the chart. Okay, it is a practice only. Okay, no hesitate that if you are mentioning wrong answer, what others may think. Okay, don't worry. Because if you are doing mistake, that means you are learning something from that mistake, right? Okay, don't hesitate in doing the mistakes, but do as many new mistakes as possible, but don't repeat the same mistake. If you are repeating the same mistake a number of times, that means you are not learning anything new. Okay, try to do as many new mistakes as possible so that you are getting enough opportunity to learn more and more, right, before your GATE exam. And definitely, since you have done more number of mistakes in the learning time, so obviously these kind of mistakes you never do in the real GATE exam, because once if you're not habituated or practiced, okay, so directly if you're attempting, then you are getting more chances to get the errors, right? But if you have practiced good number of questions and quality questions if you have solved, then while solving those questions, even when you are doing some mistakes and all, from those mistakes you are learning something new. Definitely you can overcome all these mistakes in the real GATE exam. Yeah, I thought all of you will answer this question, but still you are taking time. Okay, I will explain, no problem. See, here you are having 2/1 mux, right? So when you are having 2/1 mux or any mux, okay, you can analyze. Yes, very good, Deepu, very good. Yes. Okay, you can analyze the mux based circuit diagram with the help of truth table or with the help of stand equation also. Yes, very good, Akash, very good. You are from which branch, Akash? Yes, very good. Option A is the correct one. So here you are having stand 2/1 mux. Okay, so for 2/1 mux, you write the stand equation. Output of 2/1 mux. Output of 2/1 mux is nothing but here we are having y. And for 2/1 mux, obviously you are having single selection line, right? So when the selection line is 0, I0 will be connected. When the selection line is 1, I1 will be connected. So that is the reason either with the help of stand equation you can do the simplification, or with the help of truth table also you can get the similar answers. Yes, very good. You are from CSC. Yeah. So here in this particular mux based circuit diagram, they have given selection line as what? Q. Selection line is Q. So in place of S, you can put Q. In place of S, you can put Q. Right. Now, I0, according to the question, they have connected to ground. Ground is nothing but 0 volts. Ground is nothing but 0 volts. So that is nothing but bit value 0. Bit value 0. Next. Here I1 is nothing but P. I1 is nothing but P. So anyway, this term you will get 0. 0 and anything is 0. So that means finally you are getting P and Q. So that means option A is the correct one. Option A is the correct one. Yes, very good, Jandhyam. Actually, in fact, regarding the implementation of all the logic gates, okay, we used to discuss in our regular classes by using 2/1 muxes. Okay, right? So this is the direct question only. When the selection line is 0, that time I0 will be connected, but here our requirement is what? For AND gate, P and Q only. So that means among these two variables, you can choose one of them as selection line. The other input is nothing but I1, simple. Because when you have kept selection line as 1, that time I1 will be connected. So obviously I1 you can keep P, so I0 you can keep 0, that's all. Or even from this standard equation also you can observe here. Regarding S into I1, from there you will get simply this product term P into Q, and I0 value, the moment if it is 0, this term is going to get 0, that's all. No need of pen and paper, right? That much silly question, direct question. Yes, very good, Krishna Priya, very good. Now all of you try. This is a very good question. I can say excellent question, which is asked for GATE CS 2023 for 2 marks related to mux based circuit diagram. Why I told this question is excellent, I will mention short, okay, after some time. Okay, here you are having one mux based circuit diagram. Here you are having 4 by 1 mux, here also 4 by 1. These two outputs they have passed through 2 by 1 mux, and this is the overall circuit diagram. Okay, so that entire information they have mentioned here. Okay, and here you are having inputs like x0, x1, x2, x3, like that, x4, x5, x6, x7, right? These are the 8 inputs which you can give either 0 or 1. Regarding that, they have mentioned here, and here selection lines they have connected to the variables. Okay, and now this much whatever I have explained now, that entire thing is there in the information. Okay, everything they have mentioned here. Okay, just for reference, I have given the same diagram in the next slide. This is the same circuit diagram. Now the question is, you have to find out the here input values x0 to x7 you have to find out such that the final output you are supposed to get this answer. So that is the reason I have mentioned this question is excellent. Okay, right. So all of you give a try. I will give 3 minutes time for this question. So just by considering this slide only, you can try. That is the reason I have kept the circuit diagram also here. Yes. See, first of all, try to identify the overall mux. Whatever the given circuit is there, first try to identify what is the overall mux. Okay. So just observe, here you are having 4/1 mux, that means you are having 4 inputs and 1 output. Similarly, here also you are having 4 inputs and 1 output. Okay. So that means for overall circuit diagram, when you observe the inputs, here 4, together 8 inputs, right? Now, output of this mux we have given as input, and so here only 2 outputs we are getting, that is the reason we have used 2/1 mux. Okay. So for overall circuit we are getting single output. Now just observe this much only, I already given the hint. Now can you put the norm current for this circuit? What is the name of this entire circuit? Overall circuit is nothing but mux only, right? Here you are having 8 inputs together and you are getting single output, right? So the given circuit is nothing but 8/1 mux. So when you are having 8 inputs, how many selection lines we require? We require 3 selection lines, right? So S2, S1, S0, 3 selection lines we require. Now you can observe S2 is present here and S1, S0 present here. So you are having from input to output, you are having 2 stages. Okay, right. Now in the last step we have considered S2, and in the just one step prior to that we have considered both the selection as S1, S0. Okay, yes, very good Jandhyam, very good. So just for understanding how this particular overall circuit is 8/1 mux or not, okay, just for understanding, let us consider 2 cases. Say for example, if you have considered the selection line, say for example 0, 1, 1, suppose 0, 1, 1 you have considered. Okay, here S2 is what? 0. So the moment S2 is 0, here you are having 2/1 mux, that means this input will be connected, so you no need to worry regarding this particular mux. Okay, right. Now regarding S1, S0, I have considered like 1, 1. So for this particular mux, when you have given 1, 1, so with respect to 4/1 mux, 1, 1 is nothing but 3, so this 3 will be connected. So that means this X3 input you got here as the output, that's all. The final output for the timing I am considering like Y, so that time you are getting 3. So 0, 1, 1 is nothing but 3, so X3 input or I3 input will be connected to the output, right? Just for understanding purpose, I will consider, say for example 1, 0, 1, 1, 0, 1. Suppose regarding the selection lines, 1, 0, 1. In this case, selection line is 1, so in this case selection line is 1, so I1 will be connected, so that means the output of the lower mux we are giving as the input. Okay, in this case whatever might be happening here you can ignore. Okay, right. So 0, 1 we are having 0, 1, so in this case 0, 1 is nothing but 1, so here I1 will be connected, that I1 is nothing but your external X5, so finally X5 is coming, so in this case Y is nothing but X5. So in simple words, what we can do, when you are keeping this selection is 0, then one among these 4 inputs you are connecting. Okay, so in order to select which input has to be connected with the help of 2 selection lines, correct? So that means when you have considered the S2 as 0, here 0, 0, 0, 1, 1, 0, 1, 1. So with the help of that 1, 1 input at one time we are going to connect. Okay, similarly, the moment if you have made S2 as 1, then the lower mux output we have given as the input, so that one we are getting as the output. So here once again 2 selection lines. 4 inputs are there. So with respect to 0, 0, 0, 1, 1, 0, 1, 1, I0, I1, I2, I3. But according to overall circuit, those are nothing but x4, x5, x6, x7, like that. That's all. So that means for overall circuit, with the help of selection line combination, you are having 3 inputs selection lines. That means 8 combinations you will be having at any time. Whatever the selection line combination you have given, according to the respective input will be connected to the output. So this is the circuit diagram, which is implementation of 8x1 mux using 2 4x1 muxes and 1 2x1 mux. Okay. In the decoders, we will discuss like higher order decoders using lower order. There, first of all, we will determine how many lower order decoders required. But for coming to the mux, always number of outputs are 1. Number of outputs are 1. The number here varying is regarding the number of inputs, right? So whenever you want to implement 8x1 mux, so suppose here we have allowed to use both 4x1 and 2x1. Okay, among 4x1, 2x1, 4x1 is higher. Suppose if you have considered 4x1, then 8x4 is nothing but what? 2. So that means we require 2 4x1 muxes at the starting stage or input stage. Here 4 inputs, here 4 inputs, together you are having 8 inputs. Now from the first stage we are getting 2 outputs. Okay, now if you are allowed to use 2x1 mux, okay, so that means luckily here for 2x1 mux you are having number of inputs are 2 only. So 2 by 2 is nothing but 1. So that means we require 2 4x1 muxes and we require 1 2x1 mux. That's all. Suppose if 2x1 mux is not allowed, obviously you have to use 4x1 like that. Okay. So this is the higher order implementation of mux using lower order, just like the decoders. Okay, but decoders will start from output stage and then slowly we will go for one step prior to it. Okay, whereas for muxes we will start from the input stage and will go till last stage where you are getting output as 1. The number of outputs are 1. Okay, right. Now, in the given question, here whatever the Boolean function final output they have given, that one let us consider. Now let us do the simplification. Okay, see, I hope all of you are having the awareness that whenever you are having any mux, the output function either you can represent sigma m form or the simplified form as SOP. Okay, right. So for the time being, let us consider SOP. That means let us do further simplification if there is a possibility. So here from these two you can take A bar as common, then 1 plus C bar plus A into B bar C. A into B bar C. So here 1 plus anything is 1 logical OR. So you are getting A bar plus A into B bar C. Now this one we can do simplification by using distributive law. A bar plus A is 1, so you will get A bar plus A is 1, so you will get A bar plus B bar C. A bar plus B bar C. Yes, very good Jandhyam, very good. Option C is the correct one. Yes, very good. A bar plus A is 1, so you will get A bar plus B bar into C. Okay. Now this one you got in the SOP form. Now this one you got in the SOP form. Final simplified equivalent minimized function. But now the question is what? Here you are having 8 inputs, right? X0 to X7. So regarding those inputs, in the question they have mentioned like you can choose among zeros and ones. That means what? That means what? When you are having the truth table, okay, when you are having the selection lines like S2, S1, S0, you are having 8 combinations, right? For those 8 combinations, output either you may get 1 or you may get 0, right? That's all. So that is the reason. Now what you can do, this particular function, now try to convert into sigma m form. Okay, right. So just 1 second. Yeah. So regarding sigma m form, from SOP to sigma m, we already discussed the shortcut method in our regular classes or online class. Okay, right. So here consider term by term. Here the first term is what? A bar. That means A value is what? 0. Regarding BC, 2 bits are unknown. You will get 4 combinations like 0, 0, 0, 1, 1, 0, 1, 1, right? So directly I am writing the corresponding min terms like M0, M1, M2, M3, right? 4 min terms you will get. Next, consider the second term b bar c. B value is 0, C value is 1. Here A value, you are getting two combinations. Either A value can be 0 or A value can be 1. If you are considering 0, M1. Next, 1. 101 is nothing but 5. So if any term repeats, you can consider one time, because whatever min terms you are getting, we will sum together, right? Sigma m form. Sigma m form. So that means you are getting sigma m 0, 1, 2, 3, 5. Okay, if you want to write in terms of product of max terms, since it is 3 variable function, you will get total 8 combinations of 0s and 1s, 0 to 7. Within that range, other than these terms, remaining will be max terms. 0, 1, 2, 3, 4, 5 is present, 6, 7. So that means for these 3 combinations, you are getting 0. For these 5 combinations, you are getting 1, right? So it is very simple, luckily. And here the most interesting thing is this one. Here, whatever you got, okay, from here whatever you got, that is with respect to ABC, with respect to ABC, okay. But the most surprising thing here is what, according to the given question, if they have considered S2, S1, S0, S2, S1, S0, if they have considered like this, then these are the min terms, these are the max terms. But the most surprising thing here, what, S2 is what, B, S2 is B. So now we have to slightly modify, okay. Here I have explained this one with respect to our regular approach, okay. But actually according to this question, we have to mention like this. So here first of all write S2, S1, S0. Here according to the question, S2 is nothing but what? B. S2 is nothing but B. And then S1, S1 is nothing but A. S1 is nothing but A. And S0 is nothing but C. S0 is nothing but C. If they have chosen in the same order, then this will be the output, okay. But actually according to this question, S2 is nothing but B and S1 is nothing but A, S0 is nothing but C. That is the reason, this one more reason why I have mentioned this question is excellent, okay. So here there is a slight twist is there, okay. Now whatever you have considered earlier, follow the same approach only, but the min term numbers are going to change. So here in this case, A bar means A value is 0. Regarding BC, you will get 4 combinations, okay. Now you can write 0, 0, 0, 1, 1, 0, 1, 1. So for all these combinations, 0 only, A value. So that means here in this case, you are getting M0, then 1, M0, next M1, then M4, then M5, 0, 1, 4, 5, okay. Similarly, consider once again S2, S1, S0. Here according to the given circuit, BAC, and the second term is what? B bar C, B bar C. So here B value is 0, C value is 1. Regarding A, you can mention 0 or 1, 2 possibilities, 0 or 1, 2 possibilities. So here you will get M1 and then M3. So if any term repeats, you can consider one time. M1 is repeating, you can consider one time. So from here you are getting the final output in that sigma m. Just write the min terms 0, 1, 3, 4, 5. 0, 1, 3, 4, 5. So for these input combination, you are getting output as 1. That means the corresponding maximum numbers you will get 2, 6, 7. See, if the exam paper setter is smart, then for this possibility also there could be one option, okay. But actually you people are lucky, okay. So they haven't framed like this case any single option, okay. But those who do the silly mistake like this, they might have chosen the option whichever having accordingly, okay. For these inputs, input is 1. For these inputs, for this combination of inputs, like 0, okay. But actually now you can observe, this is the final answer for this question. This is the star mark you can put. This is very, very important. So now it is very simple. 2, 6, 7 you are getting 0. 2, 6, 7 you are getting 0. Yeah, you can observe 2, 6, 7. Yeah, remaining all you are getting 1. That's all. See, whenever you are giving respect to selection line, at any time only one particular input will be connected, right? So option C is the correct answer for this question. This is an excellent question which is asked for GATE CS 2023. Okay. Now for today's session, the last question regarding mux. It won't take much time. All of you give a try. I am giving just 1 minute, so all of you give a try. This is the last question for today's session. This is a very interesting question which is asked for GATE CS 2023. That is a mux based question, but see the beauty of these options. You are having 2 options related to combinational, 2 options related to sequential. This is a very interesting question. All of you give a try. It won't take much time. Just look at the circuit diagram and try to match which option is going to satisfy. Any guess? At least try to eliminate the wrong choices. Yeah, see here once again this is 2 by 1 mux. This is 2 by 1 mux. You are having single selection line and you are having I0, I1. In this particular circuit diagram, I0 is nothing but the output of this mux only. Earlier output of mux they have connected as the serial input. That's all. Okay. Now you can solve these kind of questions as I earlier mentioned. You can solve with the help of standard equation or with the help of truth table, right? So for the time being, I will solve this question by using truth table. Here you are having single selection line and here you are having output. For the time being, I am labeling output as y. So if the selection line is 0, then I0 will be connected. I0 will be connected. So according to this question, I0 is nothing but q. I0 is nothing but q. Next, when the selection line is 1, I1 will be connected. I1 will be connected, right? Now just observe, even this much, when you have observed that here you are having multiplexer, okay, obviously you are having single output. Okay, now just look at the options. D flip-flop you are having. D flip-flop you are having. So obviously for flip-flop or latch, you will be having 2 outputs, but those 2 outputs are complement each other. So for generalized case, if you want, you can consider 1 output. So from there you can make the other output as just complement. That's all. Okay, right. So actually those 2 outputs by default you are getting at a time, right? But those 2 outputs are complement each other. Okay, right. Now regarding half adder, you are having 2 inputs and you will get 2 outputs, sum and carry. Okay. Regarding demultiplexer, you are having number of inputs are 1, number of outputs are 2 power n, right? Even if you consider n value 1, minimum value, then you are supposed to get 2 outputs and okay, like D0, D1 like that. Okay. So that means actually the moment when you have observed this one, you have to eliminate 2 choices. Those 2 are option C, option D. Option C and option D. Okay, right. Now let us analyze among option A, option B, which one is correct. Okay, right. So just observe here. Now say for example, let us consider latch. Okay, so for latch you will be having enable. Okay. You will be having enable and your output is nothing but qn plus 1. Okay, when enable is 0, there is no change in the output. There is no change in the output. So that means whatever earlier output you are having, same thing. Now when enable equal to 1, say for example, since it is mentioned D latch, okay, this I1 if you are connecting to D. So when enable equal to 1, that time we are connecting D input to the output, right? So that means it is very simple. Directly you can say Qn plus 1 is equal to Qn when enable equal to 0. When enable equal to 0, there is no change in the state, and Qn plus 1 equal to D when enable equal to 1. When enable equal to 1. So this is the characteristic equation, right? So always with respect to flip-flops and latches, in general we will discuss with respect to the normal output, right? So now this is the reason you can select option B. Option B as the correct answer. See, for the flip-flop, you have to operate the circuit at the edge, either positive edge or negative edge. But here you are having selection line, right? So selection line means we are operating only at the level either 0 or 1, right? So that is the reason we have to choose option B. So obviously option A is not correct. So this is a very interesting question which is asked for GATE CS 2023. This is mux based circuit diagram, but the functionality wise it is matching to the D latch. So I hope all of you know that regarding mux, it is a universal element, because with the help of mux we can implement any logic gate, we can implement any logic function, we can implement any digital circuit also, provided the number of input variables and number of selections both are same. With the help of single mux we can implement any Boolean function. That is the reason we used to say mux is a universal element. Now see the beauty of this particular question. Mux is a combination circuit, but the moment when we have kept like feedback path, this particular circuit diagram is coming under sequential, and the functionality wise it is matching to the D latch. Okay, so in this particular session we have discussed all the gate questions which are asked in the 2023 paper for all the 4 branches, EC, electrical, IN and CS, and in this particular session we have covered the topics related to the first 4 chapters: number systems and codes, Boolean algebra and K-maps, logic gates and combination circuits. Based on the possibility we have discussed the questions in n number of methods, and according to the requirement we have discussed the concepts also and the other techniques, okay, which are helpful for you all in the upcoming gate preparation, right? So definitely regarding remaining concepts of the digital circuit subject, which are the questions which are asked in the 2023 paper, we'll discuss in one of the upcoming sessions. Okay, for the time being I'm keeping the suspense when that particular session is going to happen, but no issue at all. So all of you kindly subscribe our channel and click on the bell icon so that you will get the instant notification. So whenever the next session I am going to come live regarding the continuation part, okay, regarding the sequence circuits, data converters, logic family, okay, regarding those questions definitely we will discuss, but as of now that particular session date and timings are suspense for all of you. Okay, so all of you kindly share your experience, whatever we have discussed from last 2 hours. Okay, so kindly share your experience in the chat, and all of you kindly share this video link with all of your friends also. Okay, those who couldn't watch or those who couldn't attended this session live, they also can watch this particular session in their free time. Okay, right. So I hope all of you liked a lot, I hope all of you enjoyed, and I hope all of you got the very good knowledge, okay, with respect to concepts, with respect to method of solving regarding digital circuit subject. So we'll meet you all in the one more upcoming session. Okay, thank you everyone.